In this work, we investigate the perception of shape-changing haptic interfaces. We developed 3 stimuli-isolating shape-changing test devices and provide psychophysical characterization following standardized procedure. Finally, we compare the perceptual performance across different transformation magnitude, direction, and grasp type, providing valuable design guidelines. All 3 test devices are based on high-precision stepper motors and microswitches for accurate transformation and calibration. The translation device utilizes a linear actuator often found in high-precision CNC machines and 3D printers for smooth and accurate movements. The expansion device is mechanically similar to the translation device. The rotation device has the simplest mechanism with a rotating crown directly mounted to the motor shaft. These 3 devices create 3 distinct stimulus types. The translation and the rotation devices create surface misalignment primarily perceived on the skin through cutaneous channel, whereas the expansion device induces body volume change perceived by the finger joint movements via kinesthetic channel. Utilizing the 3 devices, we conducted a psychophysics experiment based on the method of constant stimuli different threshold protocol. 18 participants were asked to grasp the devices under a cover cloth while wearing white noise playing headphones. In a 2AFC fashion, the device presented 2 stimuli back-to-back. The participant used a Python GUI to log which stimulus they perceived as larger. Through the GUI, participants could trigger the stimuli via buttons, then were given 2 additional buttons to record the answer once both stimuli were triggered. Each participant made 28 comparisons under each condition on each device to collect enough data to fit psychometric curves. For each device, we chose 2 standard stimuli magnitudes, 2 grasp types, and 2 transformation directions to compare the influence on perception. After collecting all the comparison responses, 3 types of analysis were performed. The collective results fit psychometric curves on all participants' responses under a certain condition to derive psychophysical metrics, namely the point of subjective equality, just noticeable difference, and Weber fraction. Bootstrapping was used as a non-parametric statistical method to infer statistical significance and to quantify the size of effects when comparing different devices or conditions. And finally, a questionnaire qualitatively assessed each participant's subjective opinions on the devices and conditions. Here we conclude our key findings. First of all, bigger transformations always correspond to better sensitivity, violating the Weber's law. Secondly, more fingers do not guarantee a better sensitivity. It may only help for subtle, simple, or kinesthetic cues. Thirdly, no directional bias was observed for surface misalignment stimuli. Only non-significant differences was observed in the expansive motions. Finally, we also summarized some stimulus type trade-offs in the paper. Thanks for your attention.